Alright, Algebra, today we are going to continue our work with linear equations. We're going to look at a different form of a linear equation. So I believe I mentioned in the last video that anytime we have an x to the first power and a y to the first power in the same equation, we end up with a line if we were to graph that. Now, most of the time, we're going to be dealing with slope-intercept form, which is what we've been doing for the last few days. But there are other ways that these are commonly written. The two main ones we're going to look at are standard form, which we'll look at today, and point slope form, which is another interesting one, another interesting way to get to that equation of a line if we have a couple points, but we'll get to that later. So today we're going to look at the standard form of linear equations. So what is the standard form? It creates a line, just like I said, just like a slope-intercept form equation would. And it looks like this. We've got ax plus by equals c. And don't freak out because that seems like a lot of letters going on, a whole lot of stuff. The a, b, and c are what are known as constants, which means they're not variable. So when you're doing your work, it's not going to be this general. Those a, b, and c, those are going to be numbers like -2 or +5. So what we do need to keep in mind, though, is just like in slope-intercept form, we have to have the x and the y there, or else we don't have a linear equation. But a, b, and c in this general equation here, those are just going to be numbers. All right, and here's the other deal with standard form is we don't really want to use it. We're going to take those standard form equations and we are going to put them into slope-intercept form before we graph them. So how can we do that? There's actually a pretty nice three-step process that works every single time if we're starting from standard form and we want to get to slope-intercept form. And we'll do a couple of examples of this here in a minute. Okay, so step one is to move the x terms. We're going to have a 3x or a -2x or a 1/2 x or whatever it happens to be, and we want to move that away from the y. And we are going to use addition or subtraction to do that. Step two is we want to isolate the y term. We want to get that y by itself, and it's going to have some coefficient, some number in front of it, and we can get rid of that by either multiplying or dividing, depending on what's in front of the y. And then step three, you may end up with some fractions that are not in most simple form, so just put them there. The hard work's already done. We just need to simplify any fractions that are left over. Okay, so let's take a minute and let's look at a couple examples of standard form equations that we want to put into slope-intercept form. Okay, so I've got my first equation here. We've got 3y minus 4x is equal to 9, and I've got my whiteboard handy right here so we can do a little bit of work because Delta Math doesn't allow me to do that directly on the page. So maybe the first thing I'll do is I'll copy this equation over here so we can start working on it. So 3y minus 4x is equal to 9. And we want to get this into our slope-intercept form, so we want to make it look like y equals mx plus b. Now, like I said, we do the same three steps each time. Our first step is to get rid of this x term, and we're going to always use addition or subtraction here. Well, since we have a -4x, that means we want to use a +4x to get rid of that. And since we're doing it on one side of the equation, the rules of algebra say that we need to do that on the other side of the equation also. So these two terms are going to become a 0, and that just means that we're left with a 3y on the left side of the equation. And then on the right side of the equation, we're going to have this +4x, and we still have the +9. We haven't done anything with that yet. Okay, so step two was we need to isolate this y term. We need to get y all by itself, and we can do that by dividing by 3. And we need to divide both sides of the equation by 3, and this is where we need to be really careful. When we are dividing both sides of the equation by 3, that means we are dividing every single term. So all three of them we're dividing by 3. So let's see, we've got this 3y divided by 3. That just leaves us with a single y, which is exactly what we wanted. We're going to leave this as an improper fraction on the x, so we've got 4 over 3. So this is the nice way to keep the slope. It lets us to know if we were to graph this that every point we make, we're going to go up 4 and over 3 to get to the next point. So that's why we leave it that way. And then we've got plus 9 over 3, which is just 3. So 9 divided by 3 is 3. Now step 3 would be to simplify any fractions that we might have, but this 4/3 is already in most simple form. So we're done, actually. We can just go ahead and put in this y equals 4/3 x plus 3 into our equation, and we should hopefully get the right answer here. So we've got y equals 4/3 x plus 3, and we'll hit enter there and submit that, and we do have the correct equation. Okay, and as always in Delta Math, it shows you their method for doing this, and it's the exact same that mine is. There's really only one good way to do these. Move the x, divide, get rid of the coefficient of y, simplify if you need to. Okay, I'm going to have you try this one. So take a second, and in y equals mx plus b form in the box here, go ahead and change this standard form equation to a slope-intercept form equation. Okay, so let's erase our work from before here, and let's start again. So let's see if you get the same thing that I got here. So we've got 4x plus 4y is equal to a negative 32. Okay, so step 1, get rid of this x term on the left side, move it to the right side. We've got a positive 4x here. That means that we need to subtract a 4x from both sides. That's going to leave us with just 4y on the left side of the equation. And we're going to be left with a negative 4x and then a minus 32 on the right side. So be careful here. This started with a negative, so it still has a minus here. All right, our next step is to get rid of the coefficient of y. So that means that we need to divide both sides of this equation by 4. All right, when we do that, we got 4y divided by 4. That just leaves us with a y. And then we've got a negative 4 over 4x minus 32 divided by 4, which is 8. Okay, and then our last step here, we can reduce the slope of negative 4 over 4 to just actually a negative x. So this is essentially negative 1 for our slope, but just our general way that we write this is to not put the 1 there. So we're just going to have negative x minus 8. Now I do believe in Delta Math, if you put in negative 1x, it will still give you the correct answer. But in general, the way that you're going to see this in most math classes, most math books, is just a negative x here. So let's go ahead and punch this in. Y equals minus x minus 8. And we will submit that answer, and that's got it. Okay, so we're going to get some more practice with this in class. Bring any questions that you might have, and I'll see you then.